Hi student, here we design a stable multivibrator using IC555. So click on PSpice student. From that select the schematic. Now schematic window will open. Now file new schematic window will open. Now we select the different components. So for that select draw and get new part. Right here 555 IC 555, select this, place and close. So here triple IC5 is placed. Okay. Now as you know, for the astable multivibrator we require 3 external components and resistors and 2 capacitor. So for that we again go to the draw, get new part. Now right here R, place and close. So here we place 3 resistor, 2 and 3. Okay. Now place capacitor, again draw, get new part, write here C, place and close, 1, 2. Now we require the power supply for the IC555. Now again draw, get new part, write here VDC, place and close. So here we place the power supply, DC power supply. Okay. Again we require ground point. For that draw, get new part, write here ground, earth, place and close. So we require 3 ground terminals, 1 here, 1 at the output and 3. Okay. So we take the 3 like this. Now we have to connect all these components. So before we connect, now we rotate these components. So place the cursor on that component, place Control R, it will rotate. Again here same, Control R, this will this Control R. Now we want to move this, so move to the proper place. Yes. Now again Control R, so rotate this like this. Okay. So we move here. Okay. Now take wire and take wire. So from this we take wire and connect all the components. As you know, pin number 4 and pin number 5 is connected to the VCC. So we connect this to the pin number 4 and pin number 8 to the VCC. So this is pin number 8 connected to the VCC. Okay. Next, also this R1 resistor is connected to the pin number 1. So we connect this R1 resistor to the VCC. Now we connect these 2 resistors. We again draw here. Now make pin number 2 and 6 short. And 6 short and take wire from this to the okay. Pin number 7 is connected to the RA and RB. So pin number 7. Pin number 5 is connected to the capacitor C2. Select wire. Pin number 5. Connect pin number 1 to the ground. Connect the load resistor to the output pin, pin number 3. Okay. Now all connections are made. Now place the value. So right click on R1, double click. So R1, substitute the value R1, we substitute this value is 33K. Save. Okay. R2 value 10K. Save. Okay. C1 capacitor is 0.1 micro. Save. Okay. C2 0.01. Save. Okay. Next load resistor 10K value 10K. Save. Okay. Next VDC DC value 15 volt. Save. Okay. Okay. Now place the marker where we want to see voltage marker where we want to see the waveform. So we want to see the waveform at the pin number 2, that is the capacitor charging and discharging, and at the output pin, pin number 3. So here we complete the schematic. Now we want to save this file. For that, go to the file, save, name 555 Astable. Save. Okay, now this file is saved. Now analysis, go to the setup. Now select the transient. This here 0.1 millisecond, 10 millisecond, okay, close. Now simulate, analysis, simulate. So you will observe the window. Okay, so this is this red waveform for the capacitor and this green waveform for the output waveform. So we get the rectangular waveform at the output pin number 3. So capacitor charge, for the Astable multivibrator, capacitor charging from 1/3 VCC to the 2/3 VCC. Here in our case VCC is 15 volt, so 1/3 VCC is 5 volt and 2/3 VCC is 10 volt. So see here, so capacitor charges from 5 volt and this is 10 volt. Okay, so this is about the capacitor waveform charging from the 1/3 VCC to the 2/3 VCC and discharges from 10 volt to the 5 volt. Okay, now we can also calculate find out the time period from the graph. So place this, so we get the probe cursor. So place the cursor, see the cursor. So take any reference point. So we take here this. So A1. So A1 is 1.0732. Now move this cursor to this point. So here our one time period is complete, one cycle complete. So this is again 4.756. Okay, so take the difference of A1 and A2, you will get the total time period, and this is about the 3.6915. If you take the inverse of this time period, you will get the frequency, and that frequency is about 270 Hertz. Okay, and if you calculate theoretically by formula, 1.1 time period frequency is equal to 1.44 divided by RA plus twice RB into C. So we get the 271 Hertz. So this is about the Astable multivibrator.